Let's do a little refresher of Statistics 101. I mean, this is like elementary school stuff, but good to go through it again and kind of appreciate the differences and how these different techniques are used. Mean, median, and mode. I'm sure you've heard those terms before, but it's good to see how they're used differently, so let's dive in. Let's move on to mean, median, and mode. This should be a review for most of you. I think they teach this stuff in elementary school these days, but just a quick refresher now that we're starting to actually dive into some real statistics. Let's just look at some actual data and figure out how to measure these things. So the mean, as you probably know, is just another name for the average. To calculate the mean of a data set, all you got to do is sum up all of the values and divide it by the number of values that you have. So let's take this example here. Let's say I went door to door on my neighborhood and asked everyone how many kids do they have, how many children live in their household. That, by the way, is a good example of discrete numerical data, right? Remember from the previous lecture? So let's say I go around and I found out that the first house has no kids in it, and the second house has 2 children, and the third household has 3 children, and 2 and 1, and so on and so forth. So I amass this little data set of discrete numerical data. And to figure out the mean, all I do is add them all together and divide it by the number of houses that I went to. So in that case, it comes out to 0 plus 2 plus 3 plus all the rest of these things divided by the number of houses that I looked at, which is 9. And the mean number of children per house in my sample is 1.11. So there you have it, mean. Now median is a little bit different. The way you compute the median of a data set is by sorting all the values and taking the one that ends up in the middle. So for example, if that was my original data set, I could sort it numerically, and I can take the number that's slap dab in the middle of the data, which turns out to be 1. So again, all I do is take the data, sort it numerically, and take the center point. That's all there is to median. Now there is one nuance. If you have an even versus an odd number of data points, then the median might actually fall in between 2 data points, right? Like what if I had an even number there of data points? It wouldn't be clear which one is actually the middle. In that case, all you do is take the average of the 2 that do fall in the middle. So if you have an even number, you just take the middle 2. Now in this example, the median and the mean were pretty close to each other because there weren't a lot of outliers. You know, we had 0, 1, 2, or 3 kids, but we didn't have some wacky family that had 100 kids. That would have really skewed the mean, but it might not have changed the median too much, right? And that's why the median is often a very useful thing to look at and often overlooked. People have a tendency to mislead people with statistics sometimes, and I'm going to keep pointing this out throughout the course wherever I can. But for example, you can talk about the mean or average household income in the United States, and that actual number from last year when I looked it up was $72,000 some odd dollars. But that doesn't really tell an accurate picture of what the typical American makes, because if you look at the median income, it's much lower. It's $51,939. Why is that? Well, because of income inequality. There's a few very rich people in America, and the same is true in a lot of countries as well. America's not even the worst. But you know, those billionaires, those super rich people that live on Wall Street or Silicon Valley or whatever, they skew the mean, right? But there's so few of them, they don't really affect the median so much. So this is a great example of where the median tells a much better story about the typical person or data point in this example than the mean does. So whenever someone talks about the mean, you have to think about, well, what's the data distribution look like? Are there outliers that might be skewing that mean? And if the answer is potentially yes, you should also ask for the median, because often that provides more insight than the mean or the average. Finally, we'll talk about mode. This doesn't really come up too often in practice, but you can't talk about mean and median without talking about mode. I don't know why, because it starts with M, I guess. But all that is the most common value in a data set. So going back to my example of number of kids in each house, if I just look at what number occurs most frequently, it turns out to be 0. And the mode, therefore, of this data is 0. The most common number of children in a given house in this neighborhood is no kids. And that's all that means. Now, this is actually a pretty good example of continuous versus discrete data, right? Because this only really works with discrete data. If I have a continuous range of data, then I can't really talk about the most common value that occurs unless I quantize that somehow into discrete values. Okay, so we've already run into one example here where the data type matters. Mode is usually only relevant to discrete numerical data, and if you have continuous data, not so much. A lot of real-world data tends to be continuous, so maybe that's why you don't hear too much about mode, but it's here for completeness. So there you have it, mean, median, and mode in a nutshell, and we can move on. All right, mean, median, and mode, kind of the most basic statistics stuff you can possibly do. But I hope you gained a little refresher there on the importance of choosing between median and mean. They can tell very different stories, and yet people tend to equate them in their heads. So make sure you're being a responsible data scientist and representing data in a way that conveys the meaning you're trying to represent. If you're trying to display a typical value, often the median is a better choice than the mean because of outliers. So remember that. Let's move on.